Another concept that we look at is curvature. Intuitively, curvature is a measure of how sharply a curve bends. So let's define this. A parameterization r of t is called smooth on an interval I if r prime is continuous on I and r prime of t does not equal the zero vector for any t of I. The curve C is called smooth if it has a smooth parameterization. We quantify curvature as the rate of change of the unit tangent vector with respect to arc length. In symbols, the curvatures of r is just this little k, this kappa, equals the magnitude of dt ds. Now dt ds can often be quite messy to compute, but we have a nice little trick. By the chain rule, dt dt is equal to dt ds ds dt, which this part here is just the magnitude of r prime of t. Now this is what the curvature, if we want to put this over here, this, remember, is just t prime. So you get kappa, or the curvature, is equal to the magnitude of r prime of t over the magnitude of r prime of t. So let's try to find the curvature of a circle of radius a. Well, remember, from our formula, how do we figure out what a circle is? Well, we have r of t would just be a cosine of t, a sine of t. That is a vector valued function that gives us a circle. Now, you could do the calculations, but it's quite clear that r prime of t, the magnitude of r prime of t, is just going to be a, because a cosine squared plus sine squared always equals 1, and you can do those calculations there. So how do we figure out what t is? Now remember, we have r prime of t being negative a sine of t, a cosine of t. So when we're trying to find out our unit tangent vector, this will just be r prime of t divided by the magnitude, and so we get negative sine of t cosine of t. Now, the derivative of this vector valued function will quite clearly be equal to negative cosine of t negative sine of t. And quite clearly, the magnitude of this will always be 1. We already figured out what the magnitude of this is, so therefore, the curvature kappa is going to be just 1 over a. And that was a pretty easy way to figure out what the curvature of a circle of radius a would be. If things get too hairy, there's another formula that we could use that would be able to help us figure out what the curvature is. Curvature would also be equal to the magnitude of r prime of t cross r double prime of t, all divided by the magnitude of r prime of t cubed. So using this, let's find the curvature when r of t is equal to square root of 2t e to the minus t at this point, 0, 1, 1. Well, let's figure out what the value of t should be when looking at this function. It's quite clear that we need to look at it when t is equal to 0. So we need to find kappa of 0. Now, what is r prime of t? R prime of t is just going to be the square root of 2 e to the t minus e to the minus t. And our double prime of t is just going to be 0 e to the t, e to the minus t. Pretty simple so far. So now we need to calculate what r prime cross r double prime is. Now, we could do this generically, but since we're looking at t equals 0, we could just plug it in right now and find out what the determinant with I, j, k, hat, of, plug in this one, get square root of 2, 1, negative 1, 0, 1, 1. What is this determinant? Well, we get 1 minus negative 1, so we have 2i hat. And here we get negative square root of 2, j hat. And here we get square root of 2, k hat. In other words, 2 negative square root of 2 square root of 2. So we have that part there. Now we need to find what is t equaling here to r prime of t. And we get square root of 2, 1, negative 1. And now we need to find the magnitudes of both of these vectors. So if I square each component, you get 2 plus 1 plus 1, 4. So we get the magnitude of this vector is just going to be 2. What is the magnitude of this vector? We get 4 plus 2 plus 2. So we get the square root of 8, which is just going to be 2 square root of 2. Now, in order to figure out what this is with our formula, we need to cube this part, and we get 8 on the bottom over 2 square root of 2, which in other words is square root of 2 over 4. And that will be the curvature at t equals 0.